Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python, Part 7. In this section, we are going to review important concepts. Because this course requires a lot of background knowledge, we are going to spend an entire section on this. 100% of this section is theory, and no coding because you presumably have already practiced coding these concepts in a previous course. If you haven't, you're in a bad spot because a short review like this isn't sufficient to learn these concepts and have real intuition about them. That's like trying to learn calculus from a 30-minute review. Realize that top university students struggle for months with calculus. They spend hundreds of hours working through homework problems just to be able to pass calculus. So if you think you're going to learn calculus in 30 minutes, you are obviously mistaken. Similarly, if you think you are going to learn any of these concepts from a 30-minute review, you are mistaken. So what are we going to cover in this section? Specifically, we are going to talk about the Markov decision process, or MDP. This is the framework through which we solve reinforcement learning problems. We'll talk about the components of a reinforcement learning system: the state, the environment, actions, rewards, returns, episodes, discounting, policies, and value functions. Next, we'll look at specific solutions to MDPs. If you recall, there are three main categories: dynamic programming, Monte Carlo, and temporal difference learning. Each of these three methods has their strengths and weaknesses, and one caveat is that they all look kind of the same at a high level, so you really need to have coding experience with them to understand the differences. Next, we'll look at approximation methods. These are needed when the state space is large or infinite. Table-based reinforcement learning only works for the smallest of problems, and is mainly a tool for learning the principles. Finally, since this is deep reinforcement learning, which combines both reinforcement learning and deep learning, we'll review important concepts from deep learning as well. In this course, we'll be using concepts from multiple previous deep learning courses: convolutional neural networks, recurrent neural networks, regression and classification, and so on. So you'll want to be familiar with all of that, not just Deep Learning Part 1, which is only the basics.